Welcome to Sonny's, the car wash factory. In conjunction with this training video, please reference each component's owner's manual, available at sonnysdirect.com, before performing any installation, repair, or maintenance procedure. Each manual details specific requirements and settings necessary for the safe operation and maintenance of your car wash equipment.
All right, today we're going to talk about our Omni Arch. Omni Arch is one of our best high-pressure cleaning pieces of equipment we have. It's got some unique features that we've developed here at Sonny's that help to get really good clean wheels, wheel wells, top of the vehicles, under the wiper blades, windshield eyebrows, where it's able to pivot and follow the wheels, pivot and follow the back of the car. It can get the front of the car as it's coming in. As you can see here, it can be done in electric or hydraulic. This one here, again, happens to be electric. Again, the only thing that changes there is the drive. After that, it's all exactly the same. So we'll go through the normal functionality of the unit itself, and then we can go into the back room. We can talk about, again, how to adjust the hertz or frequency on the VFD drive to adjust the RPM of this unit itself. The way this unit works is the drive motor, as it is on each basket, drives a shaft that drives a drive block that creates the oscillation of this bottom pipe to oscillate up and down. We're taking these 10 0-degree plus nozzles, we're aiming them at the vehicle, starting down at the bottom of the wheel, and we're oscillating up and down. This wide drive block is our wheel block, so this one in here is designed to work for basically a lower wheel application, and it'll oscillate about 18 inches on an average size vehicle from floor to the top of the wheel. It oscillates up and down. Water's coming from the pump through this little fitting here, into the manifold, through these nozzles, and then out to the car itself. A couple adjustments that are on here is we've got a flow control valve here with the little Aerovo oil bottle. This one filled with antifreeze, so that way if we have a leak, there's no contamination out here. No contamination in our reclaim pit. But we have two flow control valves, one here and one down in the back of the cylinder. This brass one here is the one that adjusts the speed at which this unit will turn and follow the vehicle. Okay? It's got color-coded settings on it, and it's got numbers on it. If you're in here and you want to adjust it properly, the best way to do it is to turn the pump on, stand behind it, have somebody activate the solenoid valve to make it flip, and then as it flips back and forth, you open this valve or close this valve to get the speed to follow the vehicles that are going by. Once you get that speed correct, you look at it, and if you're looking at the blue line and your number 5 is at the top of the dial, that's where you want to set it. There's a little Allen screw here. You can lock that in place, just snug. You don't want to overkill it because you're going to want to adjust it again someday. But then you can easily walk over to the other side, set it to blue and number 5, and that one there will follow at the exact same speed because the air solenoid valve is applying air to both cylinders at the same time with the same control. So it makes it real easy to adjust, one side, then go back and set the other side without standing there getting soaking wet. The one on the back side here, this valve, we like to keep it wide open because we're doing a lot of work. We're going to start in the front bumper and grill, flip, follow the front wheel. If the computer lets us, like this one will, we'll flip and stay flipped for a certain period of time in the front wheel because we want to get the back of that wheel well where it's dirty right behind the back tire, the front tire. Then we'll flip back, hitting the rocker panel, and we'll then focus on the back wheel. But once we finish pivoting the back wheel, we want to stay there for a little bit because we also want to stay pivoted to get the back of the rear bumper, back of the license plate area, and that helps to really get some cleaning and good high pressure in that area. So we can do 2 different flip sets, but we want to make sure is that with that valve wide open, it'll come home in a hurry and be ready to do the next car the same as it did the first one. So we'll be able to flip this in a minute and watch it do its flip. We can speed up and slow down this valve by opening and closing it. You'll see how it adjusts the speed, and that's how that one works. I'm going to grab a small wrench, or actually big wrench, 1 inch, and the other maintenance item down here is the nozzles themselves. These big tubes look like nozzles, okay, but technically they're just the plus extensions. When you unscrew these, there is a small nozzle inside. The nozzle inside is what we call a EG nozzle or TP nozzle. It doesn't have any threads in it like a regular nozzle you screw into your pressure gun. It's a tip nozzle. It's got a shoulder on it. It sits inside this tube. When that water goes through, these act as a venturi, bring air in, break down the stream of water into droplets and reconfigure it so it stays very tight and very strong, and it'll hit the vehicle at the same pressure it is leaving this nozzle. So if we set it 600 PSI, we'll hit the vehicle at 600 PSI, and that's important. Depending on how many pumps you run, each nozzle has a rating on it. This one here happens to be a 0002, which means we're going to run this unit here with 1 pump to run both sides. That O2 at 1,000 PSI will be rated for 1 gallon a minute. So over here we have 10 gallons a minute here and 10 there. That's one pump feeding both sides, and that's the way that one there is set up to work. If you wanted to run one pump per side, these would be 04s, and you could do that accordingly. In the Sonny's catalog, there is a replacement parts section. The best way to find the exact parts for the piece of equipment you're looking for is to go to the replacement parts section and look under the Omni replacement parts, and you'll find all of these, and even the pump size and flow rates are matched to those nozzles with little asterisks. Makes it really easy to find the parts you want. Once you take these nozzles here, if they do clog, because a lot of people run reclaim to them, we'll use our tip cleaner, and our tip cleaner will help us to unclog the nozzles. We have these available at the factory. They're real easy to use. These are basically torch and welder's tip cleaners, but if you take the smallest size that'll slide in here without filing that nozzle down, you can actually clean out anything you want. You don't want to be aggressive in there. You don't want to wear out the nozzle. You just want to knock the dirt out, flush it out, and then put it back together again. So we're going to talk about the pump station in the back room, but there's two reasons why the pump will change its pressure. If the nozzles clog out here and we're trying to put the same volume of water through less nozzles, our pressure will go up. If our nozzles wear out after a period of time being used, our pressure will go down because we're trying to put more water through a bigger hole, our pressure will drop. Most instinct people have is to go back there and turn the pressure up when they see the gauge drop, and that's a mistake. You really want to, when the pressure drops, go out there and check your nozzles, replace them. Get on an annual basis. Changing the nozzles will save water consumption and maintain your cleaning performance. The lower the pressure, the less the cleaning. Every time you crank that pump up, you're using more energy to run the pump and more water to drive out here, and you don't want to do that. So you want to actually try to get everything to run back to where it was in that application originally, okay? We'll drop that back inside. We'll put this one back on. And give it just a snug. It doesn't need to be overkilled and over tightened, and that's how you clean a nozzle out. We'll go back in the back room now, and we'll have Robert activate my air pressure switch so we can watch this move, and then we'll be able to adjust the pressure on and off, and we'll see how that works, and you'll be able to adjust it. We've got a small Allen screw here that once we get it set, we'll tighten that up, and then we'll lock it in place. Right now, I'm going to close the valve down so it turns really slow, so you'll be able to see that action, and then we'll be able to adjust it so it goes a little bit faster. It'll be easy to notice. Okay, Robert, let's flip it. So we can see when the valve is closed, it's a very slow fluid motion. As I open this up, it'll go faster and faster. Okay, back. And that was our wide open, gives us a nice return. So I'm going to set this at about gold and number 7. Go ahead, flip. And that one's a little bit too fast. We're going to bring it back to blue and number 5. Okay, return. And flip. And that one there was almost there. Checking to our other side that was already calibrated. We're going to go to number 9. One more time. Okay, and flip. I think that's good. I'm going to take our little Allen wrench. Now we're going to just tighten up this little set screw. And just give it a snug. We don't want to kill it because it's going to get wet and corroded. We'll go back over and set the other side the same. We'll tighten up that Allen screw. We'll get some cars in here, wash them, and then we'll be able to adjust our nozzle pressure or nozzle angle just to make sure it's correct, and we'll make sure that that works correctly. On the electric motor, it's hard to move our drive block, but when our drive block is straight out, which means this is at the center of its travel. We're just below center, and out here where the tire's going to be, we're just below center of rim, which means when we go down, we're going to come to here and up to here, which is right about where we want it. If we want to adjust our spray pattern, we can take a nozzle like this here, slide it over, and we can actually move our nozzles a little bit and adjust our pattern. We want to be a little bit wider at the bottom. Okay, so now we have a nice wide pattern. I'm going to bring this one here out a little bit more. Now we have a nice wide pattern, so we're getting a full wheel coverage down there at the wheel point. And then when this oscillates up and down, we'll go nice up and down and get an even one. That one there is full to the top, which means at the top of the wheel, which will be on the conveyor, and that one there is sitting just perfect. So this one here was actually lined up very well, but if we wanted to make an adjustment to either raise this start point or lower it to get a bigger tire or taller tires and less small ones, we would come in here and take a Sharpie or a marker, mark where we are today by putting a mark on the tube and this block, loosen this block assembly up. And sometimes you get away with just doing one side. And if we would put a mark on here, if we want to get this lower, we'd hold this in place and lower this down a little bit. We can turn it on again, put a tire here or a vehicle inside, adjust that, and then tighten it back up again. Now it'll go from a little bit lower to not as high and focus on the wheel itself. If we wanted it taller for bigger trucks, because we have more of them, we'd raise it up a little bit, okay? We'll put this back where it was because that was a really good spot, and we'll tighten this up again. But that's how easy it is to really dial in this piece of equipment so it operates at the peak performance for the type of vehicles that you wash at your wash. Some places wash a lot of trucks, some a lot of cars. Fine-tuning your equipment to do the best job on the majority of your customers is important, and that's your job, and get that done right. And you get, again, great performance and a lot of happy customers. So this unit here is the 25-to-1 gearbox. If we run it at a full 60 hertz, it'll actually run at about 70 RPMs. So this one here, at full 60 hertz, it's at about this speed here. If we want to slow it down to get a little bit more motion or a little bit more impingement, we can slow it down to about 40 hertz, Mark, 40? And you can see right here how it slows down. So we'll go back in the back room and we'll look at that as well. I think we're going to be happy with this one here up towards the full 60, 70 hertz. So let's bring it back up to 60 hertz. And you see that that oscillation there will give us a good coverage over the vehicle surface. Now these motors can handle a little bit more, so we can always take the VFD and program it to go to even 70 hertz and go to 80 RPMs if we need to. And that's the nice part of having a VFD driving any one of your electric motors. But this is 25-to-1 because normally we don't want to go a whole lot faster than that. But this is a nice steady speed that gives us good cleaning and good RPMs to get a nice, consistent, clean wheel. Okay? We'll take a look in the back room and see how that VFD acts and responds and how we adjust that hertz setting to get the speed to change up and down. So the VFD drive that's running the two-side Omnis, it's one drive running two motors. If one of these are tripped, then one motor won't work, so they each have their own overload protection. But we're reading over here, this is in the on position already, we're reading the hertz. This motor can run at 50 hertz, 60 hertz. It can actually go up to as much as 60 or 70 hertz, because the gearbox can handle that. All we want to do to slow it down as we were before, we just turn this to 40, and that's where we were before. 40 means we're using 40 hertz. That's a 1750 RPM motor at 25-to-1, so its normal speed is about 70 some odd RPMs, which is 1700 divided by the 25. What we saw as a good speed was 60. If we decide they run a faster speed, this VFD can be programmed to go up to 80 hertz or 90 hertz. And we can actually run this a little bit faster than normal. And it'll be real happy with that because the bearings in that gearbox and the ratio are all designed to do it, and that's a IP66 waterproof motor that'll run for a long time. But right now we're going to leave it set at 60 hertz, and that's how simple it is to adjust the speed control on a VFD drive.
Thank you for watching this maintenance overview video. Please visit sonnysdirect.com and review the complete owner's manual before attempting any installation, maintenance, or repair of this component. There you'll learn necessary procedures, settings, and other considerations required for the safe operation of your car wash equipment.